So dear students, you able to view the screen containing these question papers what I shared in the morning?
Yes.
Could you please confirm?
Yes.
Okay, so now what I want to do, I want to read out the correct option to these questions, and you please note it down as you already solved it, and after that you let me know what are the questions I need to discuss, and I will discuss accordingly. So the question number 1, it is option C. Question number 2, option B. Question number 3, option D. Question number 4, option A. Question number 5, option A. Question number 6, option A. Question number 7, option B. Question number 8, option A. Question number 9, option B. Question number 10, option B. Question number 11, option C. Question number 12, option D. Question number 13, option B. Question number 14, option C. And question number 15, option B. Now, what I will suggest you is that please do let me know, what are the questions. You can send me a message. Better you can send me a message that what are the questions you have doubt with, so that I can list down your doubts, and after that I will start discussing one by one. Is it clear, dear students?
Yes.
Okay, please go ahead and do let me know what are the doubts you are having. Okay, thank you. So I got one set of doubts, from okay, no. Yeah, I got it. I got it from you, Mohar. It is 5, 6, 12, and 13. What about others, dear students? Okay, Devansu, I got it as well. Disha and Svijita, if you have done it, please do let me know. Okay, I got it 6 and 13 as well. Okay, fine. So now I'm going to discuss this solution. Okay, I got it from Srijita as well. Question number 6 and 15. Okay, dear students. So now I would like to, I'm going to share my digital board with you, and from there I will be sharing those questions that you have doubt with. Okay, my dear students, just give me a couple of minutes so that I can make my make the arrangement to connect to the digital board. First of all, thank you very much for appearing these questions. All these questions are of basic level, and solving these questions will give you confidence to appear more questions in the online test platform at KonarClasses.com. So, dear students, so let me list down the questions what you have doubt. It is question number 2, question number 5, question number 6, question number 12, question number 13, and question number 15. So let me first bring question number 2. So, dear students, this is the question in which some of you have doubt, and I'm going to discuss solution to this question. So this is question number 2. So if you look into this particular question, dear students, that what has been asked here, that a hyperbola passes through 3, 3, and the length of the conjugate axis is 8. We need to find the length of the lattice rectum. Dear students, if you remember, what is the length of the lattice rectum? Length of the lattice rectum for hyperbola is 2b square by a. And to find a solution to this question, how we are going to proceed. So let me take you to this. Let me first share the solution, and then let me explain one by one. So dear students, if you look into it, that according to the question, the length of the conjugate axis is 8. So that means 2b is equal to 8, correct? And 2b equal to 8 means b equal to 4, okay? And that hyperbola is passing through the point 3, 3. So definitely x square by a square, what is the equation of the hyperbola? That is x square by a square minus y square by b square is equal to 1. This is the equation of the hyperbola. Now that must satisfy x equal to 3 and y equal to 3, and eventually we get 9 by a square minus 9 by b square equal to 1. That implies what, dear students? 9 into b square minus a square equal to a square b square. Now we know the value of b, that is 4. That means b square is 16. So we apply the value of b square equal to 16 in this in this equation, and we get 9 into 16 minus a square equal to a square into 16. After that we simplify here, we get equation, and finally we get 25 a square is equal to 144, and eventually we get the value of a is equal to 12 by 5. Because a cannot be negative, that is the length of that half of the length of the transverse axis. So what we get, the value of a is equal to 12 by 5. And already it is given according to the question the value of b, dear students. So as we get the value of a and b, so we get the length of the lattice dictum is equal to 2b square by a, that is 2 into b square, that is 16 into by a, that means 5 by 12, and we get it is 40 by 3, and eventually the correct option is option B. Dear students, is it absolutely clear? Any doubt you have, please do let me know. If you have any smallest doubt. Okay, great. So then I can go to the next question. Next question, I'll be make it available to you in another few seconds. Okay, the next question is question number 5. Okay, and I'm going to place this question in front of you. So if I look into question number 5, let me place this question first. So dear students, this is question number 5. Okay, dear students. So now, if you look into this, question number 5, what has been asked here is that for different values of alpha, the locus of the point of intersection of the two straight lines, 3x square minus root 3x minus y minus 4 into root 3 into alpha equal to 0, and root 3 alpha x plus alpha y minus 4 root 3 equal to 0 is what we need to find. Okay. So, how to proceed to this question, dear students, is that, what are the equation of the two straight lines that, and we need to solve these two straight lines. So, let me place the solution followed by its explanation, dear students. You see that, that equation of these two straight lines are root 3x, let me do it here, dear students, is that, just a minute. So the two equations, what has been given is that is root 3x minus y minus 4 root 3 into alpha equal to 0, and next one is given is that root 3 into alpha into x plus alpha into y minus 4 root 3 is equal to 0. Now, if we solve these two equations, okay, if we solve these two equations, so what we are going to get, if we solve these two equations, what are we going to get? That 3x square minus y square equal to 48. Okay, so from here, what we get is that 3x square minus y square is equal to 48. Okay, dear students. So the moment we get this thing, so we can find that x square is equal to x square by 16 minus y square by 48 is equal to 1, and this is equation of hyperbola. So either option A or option C is going to correct. But how to find the value of E? E is equal to, if you remember, that is equal to square root of a square plus b square by a square, or 1 plus square root of 1 plus b square by a square. That is equal to square root of 1 plus 48 by 16, and that is equal to square root of 4, that is equal to 2. So eccentricity is 2 and it is a hyperbola, and we get the equation, correct option is option A. Okay, dear students, I hope you got it clear. Now you may have a question that, sir, how you find this relationship? So I made a few step jump. Is that to get this one, you need to eliminate alpha from the given two given equations. This is one equation, think of the straight line, and another equation, the straight line is this one. If you eliminate alpha, you will get this equation, dear students. Okay, I hope it is clear, dear students. So now I can proceed to the next question, that is question number 6. And I am going to place that question number 6 in front of you, dear students, in another few seconds. This is question number 6, dear students. The question is that if distance between directrices of a rectangular hyperbola is 10, then distance between its foci is what? Okay. Let us first understand this question, dear students. Okay. To understand this question, first what you need to do is that what we know the distance between the directrices, that is 2a by e. If you recall that equation of the directrices, then what we get is that 2a by e is equal to 10 according to the question. So 2a by e is equal to 10, because if you look into the standard equation of that rectangular hyperbola, there are two directrices. One is x is equal to a by e, and other one is that x is equal to minus a by e. So now the distance between them should be what? 2a by e, and that is equal to 10. So from here, what we get, dear students, as we get that 2a by e is equal to 10, from here we get a relationship between a and e, and here it is, dear students. So that is equal to we get a is equal to 10 into e by 2. So that implies is equal to a is equal to 10 into e divided by 2. Now you may think that what is the distance between the foci? Distance between the foci is nothing but 2AE. So distance between the foci, distance between the foci is equal to 2 into A into E. But how we are going to find the value of 2 into A into E? So if A is equal to 10 E, that is equal to what? 5 into E. So that implies A into E is equal to 10 into, 5 into E square. 5 into E square. So that implies 2 into A into E is equal to 10 into E square. Now you may be wondering that how to find the, how we can find the value of E. But remember, dear students, it is a rectangular hyperbola. Rectangular hyperbola has eccentricity is actually root 2. And how it is root 2? For that you can look into my class note in my video lectures on hyperbola, where I discussed in details about the different concepts of hyperbola. And in one of that session I discussed about the rectangular hyperbola, and we understood that eccentricity of rectangular hyperbola is actually root 2. So that is equal to 10 into root 2 whole square. Since E is equal to root 2 for a rectangular hyperbola.
Sir, I didn't understand how it's root 2.
Okay, for that, thank you very much for asking this question. For that, you need to go through that, that study material and the video lecture. I am not sure whether you have been through this thing or not. I can discuss in details also here. Okay, so 2AE is equal to 20, and so finally we get the value is equal to 20, and we get the correct option is option D. Now as you have asked about this thing, so let me explain you about that eccentricity of rectangular hyperbola.
Sir, I have one doubt. When we have to find the distance between the two directrices, how do we get 2A by E?
Oh, okay.
Plus minus AE.
Okay. Yeah. Now, if you visualize, or if you can go through the study material, what are the equation of the two directrices?
X is plus minus A by E, and so Y is hand. Yeah.
One by one. What is the? There are two directrices, na?
Huh.
Okay, very good. So now you tell me what is the equation of those two directrices, one by one.
Plus A by E and minus A by E.
Plus A by E is not an equation, na? X is equal to
X is equal plus A by E. Yes. Sir.
Exactly, correct. Now X is equal to A by E and X is equal to minus A by E. Write down, you draw those two lines. If you draw those two lines, what is the distance between them? X is equal to A by E is in the right side of that y-axis.
Huh. Oh, okay. Okay. Yes, understood.
At a distance of A by E, correct or not? You got my point, what I'm talking about. Now it is clear, right? Why it is A by E, right?
Yes, I understood.
Okay, now, Mohor, let me explain you that why, how we get that rectangular hyperbola. But before that, we need to understand what is rectangular hyperbola. If someone can define what is rectangular hyperbola, it will be good. If you are not able to define, I can define now, and also you can look into the video lectures which is available. I always emphasize on the go to the video lectures, because there I already explained in details. So it is no point of not proper usage of time to reiterate this thing. So rectangular hyperbola is nothing but a hyperbola, but a special type of hyperbola, such that whose asymptotes are at right angle to each other. Now, if you do not have an idea about the asymptotes, you need to go through this one. I will not explain you about the asymptotes here. Then, we cannot solve the other questions. Okay, you need to go through this. So, let me explain you about the rectangular hyperbola. And what is asymptotes, that you need to go through it. I explain in details in in one of my previous lecture. So here I am explaining that what is the rectangular hyperbola. A rectangular hyperbola, is whose asymptotes are at right angle to each other, is called a rectangular hyperbola. Now, Mohor, if you want to know about asymptotes, please do let me know. Then I need to explain this thing.
Yes.
You understood what is asymptotes, right?
Yes.
Okay, great then. So then what happened is that, there are, the angle between the asymptotes of that hyperbola, x square by a square minus y square by b square is 2 into tan inverse of b by a. Okay, 2 tan inverse of b by a is the, the angle between the two asymptotes of a hyperbola. I am not telling it is a rectangular hyperbola. I am telling it is a hyperbola. Now, that will be a rectangular hyperbola when the angle between them is 90 degrees. That means what, dear students? That means this value has to be pi by 2. Now this value has to be pi by 2. So here I wrote, that means tan inverse of b by a should be pi by 4. Eventually we get b by a is equal to tan pi by 4, which is 1. That means b is equal to a for a rectangular hyperbola. Now we know there is a relationship is equal to as b is equal to a, that means b square equal to a square. And for hyperbola we know b square is equal to a square into e square minus 1. So a square into e square minus 1 is equal to a square. That means e square minus 1 is equal to 1, because a square is not equal to 0. And eventually we get e is equal to root 2. We cannot take the negative value because eccentricity cannot be negative. I hope it is clear that why the eccentricity of a rectangular hyperbola is root 2, dear students.
Yes.
Okay, great. Now I can proceed to the next question, and the next question is question number 12, and I'm going to discuss this solution. Okay, dear students, so this is question number 12. And you see here that for that hyperbola, x square by cos square alpha minus y square by sin square alpha equal to 1, which of the following remains constant when alpha varies? Okay, so let's see how we can proceed to the solution to this particular question. If you look into this particular one, dear students, so what is that? If you make an analogy with that equation of that hyperbola, that is x square by a square minus y square by b square equal to 1. So what you get is that a square equal to cos square alpha and b square equal to sin square alpha. Na? What I'm saying is that you take this equation, what is the given equation of the hyperbola, and take the standard equation of hyperbola, that is x square by a square minus y square by b square equal to 1. If you make these two, then what, make an analogy of these two. So whatever you are going to get is that a square is equal to cos square alpha and b square is equal to sin square alpha. So from here, but we know what e is equal to what? Square root of 1 plus b square by a square. That is 1 plus sin square alpha by cos square alpha. That is e is equal to square root of 1 plus tan square alpha, and eventually we get the value of e is equal to sec alpha. So coordinate of the foci is what? A into e. What is a? A is cos alpha and e is sec alpha. So a become 1. Got it, not yet, students? So a is equal to cos alpha and e is equal to sec alpha. So when you multiply, so these two, signifies that a into e cos alpha into sec alpha is equal to 1. So what are the coordinates of the foci? Plus minus a comma 0, that means plus minus 1 comma 0. That is constant. Now, if you vary alpha, it will be fixed. Plus minus 1 comma 0. It is independent of alpha. Okay, so what we can say is that abscissa of the foci remains constant when alpha varies, and eventually we get the correct option as option D. I hope it is clear, dear students, and I can move to the next question. And thank you. And that is question number 13. And I'm going to discuss this question number 13 shortly. So let me first place that question in front of you. Question number 13 says that the coordinates of the foci of hyperbola are minus 5, 3 and 7, 3, and eccentricity is 3 by 2. Now the length of the lattice rectum. So dear students, if you recall, what is the length of the lattice rectum? Length of the lattice rectum, if you remember, it is 2b square by a. All you need to find the value of 2b square by a. So according to the question, the coordinates of the foci are minus 5, 3 and 7, 3. So that means what? That means that we know that 2AE should be 7, correct? 7 minus 5, because if you see that x coordinates are only varying, y coordinates remain same, is 3. But what is varying, the x coordinate is minus 5 and 7. So definitely the 2AE, the distance between the foci, that is known as 2AE. So the distance between the foci 2AE should be the difference of their x coordinates, because y coordinates remain same. Or you can use the distance formula, whatever. You will end up with this thing, that is 12. 7 minus 5, 12. So we get the value of 2AE is equal to 12. Eventually we get the value of A is equal to 12 by 3 into 2, and as it is eccentricity is 3 by 2, so 3 by 2, that 2 will go to the numerator, it becomes 2 by 3. I hope all of you got it. So if I can write it here, I can 2AE is equal to 12, 2AE is equal to 12, and from here what we can say is that we need to find the value of A is equal to 6 by E, and that implies A is equal to 6 by E. What is the value of E? Value of E is 3 by 2. That implies A is equal to 12 by 3, and that implies A is equal to 4, correct? And that's what actually we have written here, A equal to 4. Now dear students, we can find the value of the eccentricity. E is equal to what? We know the value of the eccentricity, but our target is to find the value of B, because A you already found it out. And length of lattice rectum is 2b square by A. A already found it out, we need to find the value of B. And the way to find the value of E is that use the relationship between the A, B and E, and that is E is equal to square root of 1 plus B square by A square. Now E is equal to what? 3 by 2, so we make a square of that. So that becomes 9 by 4 minus 1 is equal to B square by A square is equal to 16, because A is equal to 4, hence A square is 16. From there we get the value of B square is equal to 20. So now what is the length of the lattice rectum? 2b square by A, that is 2 into 20 by 4, that is equal to 10. Dear students, who raised this question, whoever raised this question, if you are not able to understand, never hesitate to ask me. Otherwise, I will proceed to the next question. Okay. If any doubt is there, never hesitate to let me, dear students. Now, the next question, that is the last question for today. That is question number 15. And I'm going to place the question in front of you in another few seconds. Okay, this is question number 15, dear students. Okay, now here if you see, the question is that the eccentricity of the hyperbola. And you see that here the equation of the hyperbola is given in a general equation of second degree in x and y. Okay, and how we are going to find it out, that let's see that how we are going to find it out, dear students. Okay, and sorry. So if you look into this, given equation of the hyperbola, that you can rearrange something like this. I'm just, write it down like this. Always you need to express in terms of, that x minus, from this equation, whatever the equation is given, dear students, that 9x square minus 16y square minus 16x minus 64y minus 199 is equal to 0. If you see this equation, now this equation, if we can, rearrange, it can be written in this form. And if you recall, dear students, this is the origin shifted form. Means, its center of this hyperbola is at the point 1, minus 2. Now, what is the eccentricity? Eccentricity remains same. That's square root of 1 plus b square by a square, that is 16 plus 9 by 16, because a and b are respectively 16 and 9 respectively. So what we get is equal to 5 by 4, and eventually we get the correct option as option B. So dear students, I hope all these doubts are clear out of this 15 questions what I gave in the morning. So if something is not clear, you can let me know. Otherwise, we can conclude the class here. Now, tomorrow when we will have class, dear students, so we will be discussing some questions from parabola. So tomorrow you will be, you will get a similar set of questions from parabola. I will give a unit test, like this 15 questions on parabola. And again, similarly, we can have a class tomorrow, around this time at 6:30 p.m. to discuss that one. Okay, so you'll expect the question from me, by at around 6:30 a.m. in the morning tomorrow. So with this, dear students, I would like to conclude the class. Thank you very much.
Thank you.
Thank you.